Thank you everyone for being here, and let's begin. Okay, so first of all, what is R Shiny and what are dashboards and why are they important for research? The main goal of R Shiny and of dashboards in general is to give users the ability to interact with visualizations. For example, if you've ever created something like a bar plot or a map that you want to share, which I'm sure if you're interested in this type, you have dabbled with that at some point. What Shiny allows you to do is to produce and share images and other types of outputs, visualization outputs, that have some degree of interactivity. For example, you can select, your users can filter through conditions or hover above certain elements in order to gain more information than what could be derived from just a static plot. So the main goal of dashboards is to facilitate communication, specifically for those of you that are researchers, which most of you are somehow in the research environment, either as students or as academics. This allows you to let your readers engage more with your data and with the decisions that you made to produce these results, which often it happens that you take several design decisions, for example, when you're creating a model, and to put it all in a paper or to put it all in an appendix might be a bit too much or might not be necessarily friendly for users. Dashboards can help you overcome this. And this goes not just for academic research, but also for things like the business environment or any type of product pitch. Because this is my area, I'll focus more on research, but it is something that is to aid any type of communication in which your goal is to to allow users to engage more deeply with the data that you want to communicate to them and to make the decisions in terms of filtering outliers, etc., more transparent and easier to inspect, reuse, and discuss. Okay, so these are dashboards. This is how they connect with research. So what is R Shiny and why is this a useful tool? Well, R Shiny is a web application that is connected to your computer or to any computer that is running an R session. What is an R session? When you open up R Studio, or if you're working in another IDE or maybe in the terminal, if that is your preference, you're opening up an R session and your computer recognizes that it has the R statistical software language installed and it is able to run commands. Now, what a Shiny app does is basically create an interface between the user, whoever you want to share your dashboard with, and this computer that is running R. So we have the front end, what the user sees, and the back end, which is running the calculations. And this is essentially what makes it different from just sharing interactive plots, something like Plotly, for example. With R Shiny, or when R Shiny shines, is when the information that you want to share with your users would require them to use or to manipulate some type of coding, either to make decisions, to, for example, filter out observations, etc. However, since we don't necessarily want to share the full code for practical reasons or any other reasons, we can rely on frameworks such as Shiny. So what are the key elements of R Shiny? Again, we have what the user sees, which is something that you would see on the browser where you have a drop-down menu, you have a bar plot, and you can select different options. The options that the developer gives you. In this case, the developer is you. So this is called the user interface. And in this user interface section of our Shiny app is where we're going to code all of the things that we want the user to see and all of the options that we want to give the user. The second part of a Shiny app is the server. And this is the back end, so to speak, or the part that is actually running our code. Let's say that you want to share a linear model, which is one of the examples that we're going to see, and you want to give your user the ability to choose certain parameters. So the parameters that you want to give the option to your user to select, all of those will go in the user interface section. However, you also need to run the linear model code, for example, LM or GLM. Well, that function, that LM or GLM function, is going to go in the backend or in the server function. So these are the two key functions. We're going to keep coming back to them again and again and again, but this is the basic structure of it. Okay, so how does the R-Shiny workflow operate? Succinctly, we have the case where a user changes the input. It can be anything from color to the number of bins or to very specific or niche parameters in a complicated model. Let's say we want to change the color of a bar plot. The user selects a color, and this color or this option is stored in an object. These objects are typically referred to with this syntax that we see here, which is input and then the $sign. So Shiny collects this input, stores it in an object, and then feeds this collected input to the server. And the server uses this input to run code in what is typically a render function. So here we store your inputs or your parameters, and with the render functions in an object called output, we are going to store the results of that manipulation. And this gets fed back into the UI. So it's a loop that begins with the UI, goes to the server, and then goes back to the UI, like any other web app. Okay, so if you have never set up an R-Shiny app in your life, there is a template that comes with RStudio. I'm just going to play it very quickly, and it'll show you exactly what you do. So you go to File, you select here Shiny Web App, you give it a name, and when you give it a name, it'll automatically create a script that has the minimal template. We're going to go over an example of this, but you can already see that we have a UI, a server, and a function that connects the three. And it gives you a ready to play with minimal example. If you want to go back to this screencast or any of the other resources, again, I'll share all of the links in the project website at the end. Okay, so let's move on. Let's take a look at these basic functions, because the UI and the server in the Shiny syntax are stored in these objects. If you remember, R is an object-oriented language, so we store a lot of code, a lot of instructions or functions into objects, and then we ask R to essentially assemble them like Legos. So the two big pieces of Lego here are these two objects called the UI and the server. Of course, you will need the library R-Shiny. Now, in the most basic, let's say, formulation, the UI, this object that will have all of the options, is something called a fluid page. Inside this fluid page, we are going to store all of the options that we want to give the user. So this is basically what will structure the HTML code that the user will see, or the Reveal.js code, or whatever type of code that the user will see in the browser will be stored here inside UI, and we typically wrap it inside a fluid page or similar function. And then we have another, which is the server object. And here, server, we are creating as a function of two things, inputs and outputs. As I mentioned before, the user will we will collect information from the user, we will store it in objects called inputs, and we will use that to update or create objects called outputs. All of this is happening inside this function that is, that you can create yourself, or it is already wrapped up in the template. And inside of these brackets, we're going to put all of the code, all of the R code that is going to be running in response to the options that we give the users. And then finally, this code here simply runs the application. So this is the basic structure. Now let's go a little bit deeper into, well, what can you put in UI? What can you put in server? And we're going to see some examples of how these two interact with each other or play with each other. Also, as an aside, if you have any questions, please write them in the comments. I cannot see them, but I will come back to all of these things at the end. Okay, so let's talk a little bit about this first object, our UI. As I said, this UI is basically fed by sub-functions, like a nested doll, like the Matryoshka dolls. And here, what we are doing is a very simple user interface structure. So we're saying, okay, well, in UI, we want two things. Well, first of all, we want to create this fluid page. And inside this page, we want to have two objects. We want to have a title panel, and this will simply put a title. And we want to show a plot. So here, we have this first class of functions that is very important, which is the output class of functions. This is how we're going to connect what is in the UI with what will be output by the server. So the server will create an output, in this case, an object called myPlot, and UI will show it again. So this is a very important function. And here the structure, all that we're telling it is that we want a page that has a title and below it has a plot. And this will create the HTML code. Now, the server function is the one that actually has our code. If we go here, in this fluid page, we're not going to have anything like ggplot or histogram or any of this type of code. We're just going to call the objects that are going to create them. And these objects that are going to create these outputs are going to be defined in server. So let's go to server. Now, this is the function that actually creates the code that reacts to your user's inputs. And here is where we're creating plots, tables, etc. As I mentioned, this server is a function of two things, inputs and outputs. And here we're going to store all of our code into outputs. The syntax, if you're not familiar with R, might seem a bit intimidating, but all it is saying is, well, inside of our server, we want to create an object called myPlot inside of output. Output is essentially a list. So this is a big list that will have one or many objects that we are creating. In this case, we're creating this object myPlot. And we're going to fill it, or we're going to assign some code into it. And we're going to assign code with the render family of functions. If you recall, in UI, we have this output family of functions that is going to show things like this object myPlot. And in server, we have this render family of functions, and they are connected. To show an output function, you need some type of render function. In this case, we are creating and showing a plot. Okay, so inside of this render plot, what is happening? And here you see this strange syntax. This is what is defining the, let's say, the mini script that is going inside the function. And this is something that you're more likely to recognize, which is typical R code. So we have We're creating a histogram out of an object called df and a column called variable1, and we're making this histogram. Now this, whatever is inside here, is going to be run by the computer that is running our code. In this case, it can be your computer if you are running this Shiny app locally. If you don't know what the difference between locally and not locally is, don't worry, we're going to come back to it. But if you do, this is what's going on. So this is the script, that is the R script that is being run. And then the results of this are stored using this render plot function in this space in this output list. And this is what we can call back in our UI function. And here we're calling it back. Okay, so we have the basics of the UI and we have the basics of the server. The UI has these this output family of functions. The server has the render family of functions, and they must mirror each other. So let's go a little bit deeper into what options we can have for the input section. So as I mentioned, inputs is basically a collection. UI is essentially the structure of your HTML page that we are using to display information to our user in the form of outputs, but we are also using it to collect information from our user in the form of inputs. So this is another family of functions that interplays with UI. One is outputs, what we show the user, in the previous example, a plot. And in this example here, we are not showing something to them, but we are collecting something from them. So for that, we need this input function. And you can probably already make the connection that this input function that we have in the UI will correspond to the input list that we will have in our server. For now, that is a correct intuition, but we will come back to this later. Okay, so moving back to the UI. What is going on in the UI, or how do we collect information from the user? Well, here is where the design of the dashboard comes into play. You can collect information, for example, through checkboxes, through lists, or through text. However you want to collect it is, a design choice. But all of these choices will have their own function. In this case, we are selecting a slider input. The slider is, well, those sliders that help you select an age, for example, from a range between 18 and 99. Now, this creates this slider input and it gives us an ID. And this ID is going to be very important because this ID is what we are going to call back in our server function. In this case, we're calling this input number 1. So we are going to create this input1 object that later we're going to be able to create. And we know that because it is a slider, this is going to be some numeric value. Now, because it is a numeric value, we have certain options. For example, we can determine what is the default value, in this case 5, the minimum 1, the maximum 10, and we can give our slider input a label. So what does this create? This function here, what it does is create a user interface that has this little this little slider that starts at 1, ends at 10, where the default value before the user does anything is 5, and that stores that information. Initially, that information is going to be 5 in this object called input1. And that is what we're going to later on manipulate, or we're going to put that input1 feedback into our server so that the user can start moving pieces around. Okay, so these are the input type of functions. And of course, inside UI, as I mentioned, we also have these output type of functions. These are the things, we're still in the user interface section or in the UI. So first we are collecting information with inputs, and here we are displaying information. There's a lot of user input functions. We're going to look at them in a bit. But here, what this example is doing is it's showing a plot output. And specifically, it is showing a plot output with an ID. So this output ID, can you guess where it's coming from? Well, of course, it is coming from our server. We know that somewhere in our server function, there is some piece of our code that is creating this object called output1. And we're calling it back so we can display it inside of our user interface. Okay, so we have in the UI, we have two key functions. The input functions, in slider input, checkbox input, etc., and the output functions like plot output, table output, text output, etc. Now, let's move on to our server to see how we can start connecting these pieces. So instead of input or output functions in the server, what we have is render functions. And these render functions are basically going to create the type of objects that we want to display. It can be render plot, render plotly if you want something a bit more interactive. It can be render text. It can even render UIs themselves, which is something that we can, if you want to see some examples of, I invite you to attend this workshop that I mentioned earlier, which will be on the 21st of May. But for now, we're going to look only at the basic functions. So the render function creates the outputs that we are going to call in our interface. Remember that in our UI before, we were calling this output called output1. Well, here in the server, we see where it is created and what is the code that creates it. We are storing this output1, and here I'm just calling it like that, but you can call it however you want. You can call it histogram, you can call it Peter, it doesn't really matter. The only restriction is that this should be the same as this, so that they talk to each other. But what doesn't change is the name of the list, because we are putting this into a specific list called output. So here we're using the render function to run our code to produce a specific type of object. For example, if here instead of a plot I created a table, it wouldn't work because it wouldn't recognize that it is rendering a table. It would expect a plot. So for each element or for each type of object, we have a render function, and this will mirror our output function in the UI. And here we have very, very simple R code. So these are the three key functions. Two go in the UI and one goes in the server, and they're all connected. Now here we have a longer list of functions and what they're connected to in the server. For example, let's say that we want to have a drop-down selection. We can put the select input, and all of these select inputs will have their own options. In this case, it won't have a minimum or maximum value, but it'll have a list of options that we want to give the users. So all of these functions have their own logic, their own syntax. So it is good to first draw what you want on paper and then think a little bit about, well, what type of, how am I going to collect my data, and what are the options within each of these functions. We also have the slider input, which we collected, have a checkbox input, a numeric input if we just want to collect the number, text, date, date range, etc. And all of these things, well, all of this information we are storing in this object called input, which we can then call in the server. So we can say, well, white or red or blue or whatever color you want. The default can be white. So the value that is being stored here by default is going to be white. But if the user changes it to blue, then this object called input that is in our server function right here is going to be updated to the new value. And because it is updating to the new value, if we included that in our code, for example, in a ggplot code, we can put color equals the value of input 1, well then the plot will re-render, but this time in blue, and so on and so forth. This is especially good for things like filtering, not just for color, but I digress. Now, these are the inputs, and we call these inputs in the input section of the server. So what about the outputs? The outputs are the ones that are connected to a specific render function. For example, if you want to show a plot, you have plot output, but this needs to be paired with a render plot. If you want to show, for example, a table, great, we can put this in our UI, but this has to call an object, an output that is created by a function called render table. And inside of this, you will need some R code that creates render table. So you can also start combining all of these, or you combine all of these pieces so that you design your own app. Now, of course, now in 2026, if you are doing some type of dashboard, it is very likely that you are going to be using some AI assisted coding, which is excellent, but hopefully this will help you better understand what is going on behind the scenes, or whatever agent is creating for you can do. And it'll also help you sandbox and make design choices that are going to be much faster and much cheaper if you're using expensive models. Okay, so let's talk a little bit about how to design the layout in the UI. We recall that we have these two big functions, the or families of functions in our UI, the inputs and the outputs. So how do we want to organize them? What's going to go on top? Do we have one column or two columns? Do we have a main control panel and then a panel that shows the plots, etc., etc., etc.? How and where you arrange these inputs and outputs is going to determine how your dashboard is visually organized. And for this, I think a very good exercise, if you're doing this for the first time, is to just take out a piece of paper and draw how your panel is going, how you want it to look like, maybe do some annotations, and put it in pen and paper. Then, with that, it'll be easier to design. Now, as I mentioned before, we can organize our UI basically with this fluid page. There's also fluid row, fluid column families of functions, or some pre-built structures that Shiny has. And all of them will go in order in the code, and you can put different types or different layouts within each other. Again, like this Matryoshka doll. So here, what is going on? Well, in this example, we have a fluid page that encompasses everything, and inside it, we have this title panel that is self-contained, which basically will just have text. Below that, we have this sidebar layout. Sidebar layout is one of these pre-built layouts that Shiny has, which will assume a sidebar panel. It's going to be on either the right or the left, depending on the order, and a main panel. Inside this sidebar panel, for example, if you want to put your slider here, well, the input slider function should go inside this function, which will in turn go inside this function, which will go inside of this function, but below this function here. separated by a comma. So this is how we're organizing how the layout is going to be. Again, if you are using something like assisted coding, it's even more important to have this well thought out in your head, because that way you can draw it and essentially tell it how to organize the UI. But if you want to do it manually, it is very important to also have this mental scheme. And inside this main panel, for example, we can put other types of panels, like these tab set panels, which will have 3 tabs, and each tab will have its own little function. So this is how things are rendered. Now, I know this is a lot, and there's a lot of, let's say, things that are inside of each other. So let's take a look at a more concrete example with actual code. I don't know what that was. So here, what we are doing is this code is creating this. By the way, if there's any issue that I should be aware of here, please let me know in the comments, because I don't always see these things. If not, okay, great. Okay, so let's take a look at how this empty template was created to really drive this idea home. So the first thing that we notice is that we have this fluid page. This fluid page, which starts here and ends here, creates a blank page. It's the canvas. So how are we going to fill this canvas in? Well, here, what we're doing is first we're creating this title panel, and this is going to be at the very top. Shiny is organized from top to bottom and from left to right. So just as if you were writing in the Western tradition, starting from the top and left to right. If you don't write in that way, that might be a bit confusing, but this is how it's organized. So what we're creating is this title panel, and inside it, I put this string, which gives it the name. If I had put here the word dashboard between the quotations, here it would read dashboard. And then we have this comma, which means that something will go below it. Now, below this title panel, we are creating a new sidebar layout. And here, this starts with this and ends with this here. So everything that goes, all of this chunk of code is basically nested inside sidebar layout. In this case, something like this. And which in turn is nested inside fluid page. So what are we putting inside sidebar layout? Well, we're putting a sidebar panel, and we are calling it side panel here. We have this option here. For example, if I wanted to put a slider, I would put comma inside of this sidebar panel next to the title, and I would put input slider, for example, and it would create that. And then we close the sidebar panel. We put this comma to signal that we're moving on to the next thing. And then we open our main panel. And our main panel has its own name panel. But we notice that inside main panel, we have another layout, which is this tab set panel. And this tab set panel in turn has 2 more options, tab panel A or tab panel B. And we can click between them. So, and if you want to put different things, for example, if we want to put a histogram in here, inside this tab panel B, then we would have to make sure that we would put our render plot function right here before this parenthesis. So this is how the UI is organized. I know this is a lot of information, especially if this is the first time that you are dealing with Shiny, but the best is really to just practice and develop an intuition for it. The commas, and the main challenge here is to keep track of what goes inside of what, or what should go inside of what, which is why drawing it out somewhere in a notebook is very, very helpful. Okay, so let's move on. Now, how do we organize our Shiny apps or our projects. Now, if you've already created a Shiny app, you'll probably know that sometimes they can get very, very big. In our first example, or in the template, if you run it, the one that we saw in the video, you'll see that it only creates one file called app. And inside that file, you have a render function, sorry, a UI and a render function in the same script. Now, when you have a very complex application, this can become a bit clunky because you need to call on libraries, you need to have a very big script that has many different, let's say, functions or many different dials, and another one that has a lot of R functions. So it is useful to, or when a project blows up a bit like this, it's important to have it organized as a file or as a project. So a very small Shiny app can live inside one file, but once this grows, especially if you're adding customization, then it's good practice to organize these things in a project folder. And a project folder has a very specific structure. It's not it's not a canonical structure, but it's a helpful one. Now, if you have things like, for example, images, logos, or CSS, for those that do not know, CSS is basically a wrapper for HTML that gives it the styles or the fonts and all of the nice design options. So you can give it a nice theme and create a CSS style, and that can go in a folder called www. Why www? To be honest, I don't know. But every time that you want to display static images that come from your resources, not the plots that you create, but for example, the logo like this one here from Vilnius University, you can call it from a folder called www. If anyone has an answer for this, please put it in the comments because I'm very curious to know. But more importantly, what this allows you to do is to separate your UI and your server into two different scripts. Now, if R recognizes that you have a script called UI and a script called server, especially if it's RStudio, then it'll automatically recognize that it is an app. But it is important that your main files are either named app.r, and it's all in one place, or if you're separating them, that they're named exactly UI and server. And then you can make use of all of this projects. Also, as a general rule, keeping figures, outputs, etc., all in their own folders really helps in life. Okay, so now let's take a look at a real live example of a Shiny app. This is going to be an example that is all in one script. It's a Shiny app that is, live out there in the world. And we're going to look at different design decisions. We're going to look at specific input class objects. We're going to look at specific output class objects. And we're going to see how this renders in order to create a workable Shiny app. So hopefully it'll load. Let's reload this. Okay, perfect. So what we see here is a Shiny app that I'm embedding in the slides. There's a link for it, or if there's not, I will share it with you. And first, let's take a look at the app itself, and then we're going to look at the code. So here, what is it doing? Well, it's giving us some information. It's creating a scatter plot on the relationship between flipper length and body mass for some penguins. This is from a very fun data set called Palmer penguins. It's included with, well, it's not included with R, but it's a very famous library. So you'll see a lot of examples with this. That is why I chose it. But more importantly, it gives us a general layout of what we're looking for. Here, we are looking at, well, a title. We're looking at a box or a tab panel that has input options from us, from the users. We have a drop-down menu here. We have another drop-down menu, and we have this checkbox that we can tick or not. Then below that, we have a summary that is displaying some information in text. Below that, we have a scatter plot. So we have this plot that is being displayed. You can also see that if we remove that, this disappears. So we're changing this input. And below that, we have a table of data where we can also have different options. Okay, let's, for example, check only the species, and we see that it creates a new plot. Now, let's inspect the code that was necessary to create this very simple app. And here, let's assume that we have a file called app.r. We have this comment all around. And like with any other R script, we need to load the libraries that we're going to use. The library Shiny, creates or helps us create the Shiny app. It has the input, output functions, etc., or the key ones at least. We have this library called Polar Penguins, which is where the data is coming from. The library dplyr for the pipe. I use the old pipe. If you use the new pipe because you have a newer version of R, more power to you. The library ggplot. Why? Because this is how we're making this plot. And the library dt, because that is what is making the table. So like with any other script, we still need to load and install our libraries, obviously. Okay, so then we also need to do the data preparation. In this case, from this Palmer penguins, we are selecting penguins and we are doing some variable transformation. So we have our data set called penguins, and this is going to be loaded. This is going to be global for the environment that we're going to be working on. Then below this, we see something that we can already start recognizing from this example. We see that we are creating first our UI object with fluid page. And now we can inspect these options. Well, first, we have this title panel, the Palmer Penguin Shiny demo. Then below that, we have this sidebar layout. Now here, because it's very narrow, it doesn't show them side by side. But if you were to see them in a different format, then instead of being summary below the sidebar or the scatter plot below the sidebar layout, it would show next to it. But let's take a look at this layout. Well, first we have a sidebar panel that has our select input. This is our first option, which says, well, the label is species. So this is an object, or this is an input called species that we're going to later call in our server. It tells us, well, what label do you want to display? What instruction do you want to display to the user? In this case, choose species. And the choices. And here, notice that the default will be all, but then we have some R code here. And these are going to be the levels of penguins at species. How does it recognize this? Well, because before, up here, we're already defining it. So there's already an object before we run into all of this called species. If you want to also separate the data preparation from user and user interface and server, you can also create a third file called global.r. So this returns a string, and this goes into this concatenated series of strings. And all of this will go into one very big list that has all of the options: Adelaide, Chinstrap, or Gentoo. These are types of penguins. Below we have another select input, which is choose island. Same logic, only instead of species, island. And we are creating a new input ID called island. This is important. And finally, we have this trend line. And here, this is a checkbox, which is going to be, instead of choices, value true or false, where the default value is always the default option, is going to be true. Okay, so this ends this section, which is our sidebar panel. This ends here. Then we have our main panel, and we see the options that are being or the visualizations that are being displayed to the user. We see first a header. H3 is header 3. It's HTML code or semi-HTML code. And we see summary. And then below we have this verbatim text output. And this is basically calling something called summary text. Now, where is this summary text coming from? Well, we know from what we've talked about that somewhere in the server there is an element called summary text that is being stored in the big object, called output. So let's look for this. And we also have this other, below it, we have this H3 scatter plot. So this is the title. And we're calling a plot output. So we have these two classes of outputs. One is text, and it produces text. And another one is plot, which produces plot. And below it, we have a data table plot, which again is displaying an object that is rendered in the server called Penguin table. Okay, so we know how this is structured. We see how this whole thing is built. Now let's, or at least displayed for the user. Now let's take a look at how this is created, or how this how these elements are being actually run in the server. So let's take a look at the first one, which is summary text. So inside of our server function, we know that indeed we have inside of outputs an object called summary text, and inside of it, and this is created by this render print function. So it'll create something that is going to be printed. And this, the pair to this is going to be this verbatim text output. It can also be a different type of output. With text, it's a bit more flexible. With plot, a bit less. They all have their connections, and it's a bit of trial and error, to be honest. But in this case, what are we doing? Well, all of this is running our code, and this is where you start seeing all of the advantages of having this React type structure, or being able to update our code. Now, it's telling us, well, our data is going to come from the object penguins. This is defined globally above here in line 17. But then we have certain options. Like, for example, we are going to give an option here, or like a condition that is, if input species is not all, or is different from all is going to be the default. If the user changes it to anything else, then data becomes filtered by whatever value is for species. Remember that filter selects certain rows. Now, let's do this here. Let's go to all. And we see that in summary, we see for all of the species, we have 344. Why? Because we're calling this data, and here, because we selected all, we're not filtering anything. But what happens if we filter for the species Adelaide, or Adelaide? Well, this gets updated. And here, since species in input is no longer all, it is different from all, it is now Adley. Well, we then meet the condition to run this code, and we filter species for Adley. Now, data becomes smaller, and therefore, when we run this function, which is concatenate, which is basically like print, we see rows is now n row data, but data is no longer just penguins, but penguins filtered by Adelaide, because we have this condition here. And voila. The same if we do it for Chinstrap, and the same if we do it for Bisco. And here we see that There are no chinstrap penguins in Biscoe Island, and so on and so forth. So for this, if you want to take a look at this in more detail, please follow the slides. I will share them with you. And before we move on to some more real world examples, I also want to show you this ggplot. Yeah, let's go to the ggplot first, just to emphasize this point. Let's put them all here. Let's put them all. So just the last one, because otherwise we will forget. So this creates this summary text. Let's go to see this output called the scatter plot. So the scatter plot, we go to the object called penguin plot. And here, what we see is, again, these conditional filters, more additional filters here. And we see that we can create this object called ggplot. And we're storing this ggplot object, this scatter plot, inside of the object P. Now, here is another condition. We can add this true false to see whether it'll re-render automatically this plot. In this case, we're saying whether we want to show the regression line or not. Now, most of the very basic the basic render functions like print, render plot, input, they are all included in the Shiny app, in the Shiny library, but some are not. Some functions, for example, like render plotly or input, not render plotly or plotly output, or in this case, render DT or output DT, as we see here, DT output. They're not included in the main Shiny library, so some packages will have their own type of input and output functions. In this case, there is a native input and render function called table output and render table. But if you run, or if you try to run a DT type object, as we're doing here, we're not just running a table, but we're running a data table, which is a specific type of table that comes from the package DT, then it will not run. So this is just something to be careful with. Whenever you are using some functions that might be a little bit more exotic or more sophisticated, just make sure that you load these libraries, because the render and the output functions might not be included in Shiny. They will, if they exist, they will be included in their own libraries. And for some more niche packages, they might not exist. So this is our minimal example here. Have our UI defined, and we have our server, and they're connected with each other. Okay, so finally, before we wrap up for some Q&A, I want to show you some additional dashboards, some other examples of dashboards, and I want to go back to the main objective, which is, well, why should we use dashboards for research, or what benefit do they give us? What's the point of using dashboards for research? Here is a very simple dashboard, and we didn't have to wait a while. So as you see, this is a dashboard that someone created on exercises and, okay. So this is a dashboard that someone created to develop random numbers of exercises. So you give it some parameters, and you click this button. You can also ask it not to immediately update, as our previous example, but you can create these little buttons here. Now, as you can see, this is going a bit slowly. This might be because a lot of us are currently in this slide. This is hosted on something called Posit Connect, and in the last few minutes, I'll talk a little bit about what Posit Connect is and what are some other options. But this is one example. This is not necessarily for research, but the next example I want to show you comes from my own research and is connected to this FIRSA project. And in this dashboard, which is connected to the outputs of the project, the goal here is to show the results from a statistical model where the research question is what are the variables that predict whether someone has owned cryptocurrencies in the past few years? And is financial literacy and financial prudence associated with a higher or a lower probability of of having owned or currently owning cryptocurrencies, at least in Europe? Now, this, of course, it's a working paper that you can read, but we also created this dashboard, which is the next one coming up here. And this gives us a little bit more interactivity. Now, these are some of the elements that we've seen. Here we're creating the static image that shows us the coefficients, the positive and the negative predictors of cryptocurrency ownership. And what dashboards like this allow the user to do is to interact more deeply with the data. So for example, we created this model that predicted the probability of a particular type of person, or that showed us this plot here, which tells us that, for example, those with higher digital confidence are more likely to own cryptocurrency. So this is the message or the story that this graph is telling us here. Now, what if we want to go a little bit deeper and allow the users to ask more precise questions? For example, what is the change in your predicted or in any person's predicted probability when, instead of their financial literacy score, which we also give a little option of here, now it's, hold on, I'm gonna go back to this. Well, it's not really working, which is a bit embarrassing. Okay, we'll go back to this dashboard later. We'll go back to it because I'll call it from the actual site. My embedding did not want to show up today. So going back to the dashboard, which I'll come back to after this, what are the benefits of having a dashboard, or what are the when should you use a dashboard, especially if you are a researcher? Now, the main goal of using dashboards, or the main, let's say, objective for using the criteria for whether you need to use a dashboard for research or not, is whether this interactivity that you are offering allows you to, or allows your users to interpret your results and your data better. When you're creating dashboards, especially from research, as I will show hopefully with my own example, there's a lot of temptation to put every single decision and parameter and possibility in the dashboard, and you are able to do so. However, dashboards, like any other type of visualization, they're meant to tell a story, or they're meant to support an argument. So one of the key things that should guide the dashboard design is the qualitative question. Well, what do I want to show? What is the question that I want this dashboard to answer? And what are the elements from my research? For example, what variables or what options, what geographies, what plots does the user need in order to answer this question? So this is the main guiding principle, not just, well, you should do it because you can, and you can, of course, but the design choice should be guided by, well, what is the message we want to give? And dashboards can and do improve transparency. You can show, for example, not just the coefficients of a model, but you can allow your users to say, well, what happens when you change certain parameters? Are, for example, the relationships linear or non-linear as the paper might suggest or not? How can we really, trust these results? Typically, the more transparent you are with your results and with your process, the more people can trust these results. And having a dashboard helps these arguments. Therefore, they're very useful for public-facing research, especially if you're applying for competitive grants, and it's very common to promise a dashboard. If you are doing this, I really encourage you to do so, especially if you're a junior scholar, because first of all, the costs of actually implementing dashboards or designing them yourselves have decreased and are likely to decrease more and more. And they serve a very good, they look very good on an application, but they look very good on an application precisely because it shows or they demonstrate your commitment to methodological transparency and to communicating the results of your research to a wider audience and making the argument of, well, why would a wider audience care? These are all very good reasons for for creating and implementing these dashboards. Okay, so final element, which is publishing and deployment. Let's say that you've created your dashboard. We mentioned at the beginning that you can have them locally or you can have them actually running somewhere. With Shiny, one of the things that is really neat or very useful is, especially if you are just starting with dashboards, they give you a very easy publishing option. So you can create it in your machine, you can make sure it runs, but especially if you use something like RStudio, you can very easily put that dashboard online and share it with people. Now, as we mentioned before, a Shiny app requires a server that has R running. If you construct it on your laptop, that is your machine that is running the app, right? If you are constructing this app if you want to share it with the internet, then you must have some type of server that has R running or some type of virtual machine or some cloud that has R serving. There are different options for this, most of which you have to configure yourself. But the people behind RStudio, the Posit company, they make your life pretty easy and they allow you to simply deploy them onto their servers, especially if you have smaller projects. If you have something a lot bigger, then it might get a bit pricier and you can consider other options. But for 80% of all projects, I think Shiny Apps IO, which is very easy to connect or to create a free account, you can run it. If you want more advanced options that give you more flexibility, there are things like Docker and Google Cloud Run. And if you're interested in this and of course, you enjoyed this session, please join us on May 21st with this Workshops for Ukraine initiative, where I talk precisely about how to host Shiny apps in the cloud. Okay, so finally, here we have a little GIF. If you created your very nice Shiny app, all you have to do here is click publish, you create an account with their site, and if your code runs well, voila, it helps. And finally, I am going to show you the dashboard of the project, but I'll run it from the website, the actual website, instead of the slide. Hopefully this will work. Yeah, okay. So back to this FIRSA dashboard and going back to this issue of transparency and replicability. So what is the objective of the dashboard? It's to turn this very static story here. In this case, the example is, well, what are the predictors of someone owning cryptocurrency, into something more interactive that shows, well, what is the effect of having a higher degree of subjective literacy, and here we see that it is measured as a quiz, on your predicted probability of owning cryptocurrency. And this really makes it a lot easier for users to gain an intuition of your results. What does this show? It shows that the more your financial literacy is, at least according to the survey data, the higher the likelihood that you have owned cryptocurrency. You can also see the effect of, for example, being male versus being female. If you are male and young, the odds of you owning crypto are greater than chance. If you keep everything the same, but instead you are female, well, that probability decreases significantly. So it allows us to tell a more compelling story than one would just get from looking at the static plot or the static table, which are included in the paper. And the Shiny app is like any other website. It's very flexible. You can also, for example, show how the data was collected. It comes from this quiz. It points to the main source, and it allows users to, I'm just going to run through this, to, for example, get a sense of how your data was collected and to get their own sense of, well, how much can we trust this? Is this, for example, questionnaire a good enough metric of financial literacy? I will let you explore it, and you can also, of course, share your documentation and share the entire code base on things like GitHub, etc. So what this really does is it helps you, as I mentioned, it helps you make your projects and your research a lot more transparent. And this is the overall goal here. Now, I'm going to stop talking here. Thank you very much. If you want to learn more about this, or if you want to look at the recording, please follow the project website, the FIRSA project.